My name is Upmanu Lall. I'm at Columbia University and the Department of Earth and Environmental Engineering, and I'm also the director of the Columbia Water Center. So it's my pleasure to welcome you to the fourth America's Water event that we've had, fourth annual. The previous three events were focused on the United States in different aspects, and we primarily invited people to come and discuss their perspectives on what it means to look at water in the United States. This year, we are extending that to the Americas, which was our design from the very beginning. And so I'm very happy that we are making this transition because in part, the next talk is going to be by President Bollinger from Columbia University, and he's going to talk a little bit about his vision for the Columbia World projects, of which this could be possibly one of the directions that we start looking at. The way we have done these events is a bit different than what many people do. We usually invite outsiders to come and talk and have a discussion, and then we have working groups where we try to come through with some direction towards solutions from the visitors again. So unlike most organizations, this is not an attempt to showcase what we at Columbia are doing historically. This year we changed things a little bit. We have a few posters here so that during the breaks, you guys can get some sense of what we do. But the mode is still the same. We are not trying to push things that we do onto you as such. So the plan for the day is we'll start out with President Bollinger welcoming us. Then we will have a video from the President of Peru, and I'll introduce that. And then we'll move to a talk by me, essentially setting the context for today, and then we'll have things that go on. This particular event is supported by the National Science Foundation that's been funding us for some time and is co-organized with WaterAid America. So with that, let me invite President Bollinger to say a few words.
Good morning, and thank you for having me, Mano, for this little part. I just want to say a few things about how the university is thinking about problems, world problems, and how to solve them, and invite you in the course of your discussions to, if you would, also think about how the problems you talk about might be translated into a more larger university kind of project. So I'm just going to outline the concept, the way in which we're thinking about this here at the university. Ken Pruitt is in the room right over here, and Ken and I have been working on this along with a couple of dozen faculty, including Upmanu, and for the past year, 2 years. And we're at a point now where we're almost ready to announce a major new initiative by the university of this nature. So during the day, while Ken is here, if you think of things, please talk with him. So the basic outline of the concept is the following. The world is under enormous stresses, has enormous needs. I mean, this is, almost banal to point this out, begin with it. There are many ways in which people talk about the problems of the world. I mean, you have a simultaneous phenomena of a greater and greater integration of the world through economic activity, through communications technologies, and so on. So this is part of the modern world. At the same time, you have a resistance to this. You have winners and losers. You have inadequate institutions in the world to grapple with these problems and issues. You have what some people would refer to as a lack of public goods to be able to deal with this. We have institutions that were designed in the post-World War II era, which have worked reasonably well over a period of time for that world, but we do not have a set of institutions in the world prepared to address the problems and issues of the current kind of reality. Meanwhile, we have a rise of authoritarianism throughout the world. You have very, very grave concerns about whether democracies can function, whether truly autocratic systems of government are going to become sorry model for other countries. I mean, it's a time really of enormous stress. This raises the question for us, what does this mean for universities? And I think this is what we have to confront in a very, very serious way. There are some, again, people who observe that the way the world's problems are addressed today, given the insufficiency of public goods, is through a combination of actors in the world. It's certainly governments, but it's also civil society, and it's universities working with NGOs, working with governments. This is the method of dealing with problems such as climate change, the internet, et cetera. So universities are already called into play in world governance, as it were. You can say that's something that's sufficient. I would not. I would say there is much, much more that we can do. We can be a much stronger participant. But it also makes the point that there is an invitation that's right there to participate in solving world problems. So the great question is, given a magnitude of problems in the world, which we can all talk about and identify, what is the real role for universities? So when you look at universities and how they're structured, we know that faculty, it's built around a model of hiring individual faculty who are highly gifted, who become experts in fields, and largely working within the confines of disciplines. And they, in this highly decentralized world, produce over time very, very beneficial work. So universities are among the most successful institutions ever invented. The structure is, as I call it, bizarre. I mean, no university, no person, sane person would step back and design a university according to this idea. It just doesn't seem to fit with anything. But it works magnificently. Within that structure, there are some parts of the university that actually do focus on outside problems, on blending that work with the basic scholarship, with outside consequences. Medical schools are the prime example. So we have both basic research about medical issues, biological issues, and we have people who take that right in our own facilities and go out and operate on people. And so there's a combination of basic research and practice. We have other parts of the university, some institutes like Upmanu's, Earth Institute, some centers that are intended to try to link basic research and knowledge with outside problems. We have some individual faculty who take this on. We have tech transfer, where we try to get our knowledge into the commercial sector. All of this is great, but it, as a fact, could be much, much more significant if a university said, this is actually our mission. It's not just, it will happen in a school, and they'll happen sort of haphazardly around the institution, but we will actually make this a purpose of the university. So it would be research, teaching, public service, which is a kind of volunteer activity I think of, and this new dimension, actually a new purpose. So then you say, well, what would you have to do to make that happen? And you'd have to do many things. But first of all, you'd have to have a whole infrastructure for this. You would have to have space devoted to it. You would have to have funding for this. You would have to have researchers who were prepared to help work on projects, project managers, legal staff, all the kinds of infrastructure that you need to make things happen. We want to have a law school, we build a building and buildings, and we have admissions officers, and we raise money, and we have students, and so we need that for this dimension as well. We are in the process of doing all that. We are bringing in people to provide this staff. We have space in a new building in Manhattanville that will open up in a year that will begin to house this. We have raised funds. We have a fundraising apparatus around this. We have faculty prepared to devote themselves to creating this, and that's all great. We would have to, I think, do something which is quite hard to do for academics, and that is to work collaboratively. So the model is individual faculty write their books, do their lab work, etc., and we all talk about working collaboratively. But the fact of the matter is, except for a few instances in the history of the Academy, like the Manhattan Project, maybe climate change, maybe a few other things you can identify, we've never really said, at times the problems demand, given their scale and importance, the demand that we work not as individual faculty who kind of decide whether we want to work together, but we actually have to work together in teams and groups. A good example in the modern world is CERN, the great facility for advancing our understanding of theoretical physics, and the necessity of people working together in teams of hundreds, even thousands. We'd have to work across disciplines. That's fairly easy. We all talk about interdisciplinary work. We do it to a certain extent. But when we talk about water, where are the anthropologists, where are the humanists, the linguists, the law people, it's bringing together all of those. But then there's another dimension, which is actually we could, decide that water, as we are, that water is a huge, huge subject, and we need to bring people together and work collaboratively and so on. And I would say to you, I do not think we have the intellectual resources in our universities devoted to the subject of water that the problems call for. So we've got Upmanu, and we've got several people in this room, and that's fantastic. But we need several dozen Upmanus. I mean, this is crazy. I say this with real knowledge, because I was a dean of a law school for 7 years, and my closest friend, my colleague Joe Sachs, one of the great environmental law people, really invented the field in the 1960s, was somebody who really was very careful about aligning his work in environmental law and with the outside world. And he knew he had to go into the field of water law. And he wrote the best case book on water law that existed. He died 2 years ago. And I learned about water law through my friendship with Joe Sachs. One of my jobs as dean of the law school was to take new young recruits, typically just off a Supreme Court clerkship, so they're about 27, 28 years old, and talk to the new faculty member about what they were going to teach. And I would always say to the new faculty, you tell me what you want to do, and I'll say to you, I think you ought to work in the area of water law. I mean, other than Joe Sachs, there's nobody who really is of Joe's quality who's working in that field. He defines the field. Within a space of a year or two, you could be one of the leading people in an extremely important field. And the person would always say, thank you, really good advice. I think I want to teach constitutional law. And that would be the 15th person teaching constitutional law. So the fashion of intellectual work is to go where, you think the hot subjects are. And meanwhile, we are left with a university world that simply does not have the intellectual resources. So we need to build that up if we're going to be serious about dealing with outside problems. So we need to do this at a university level, et cetera, et cetera. One of the things you have to do is to identify and work with outside partners, because we are very, very good at doing thinking, ideas, research, advancing knowledge, teaching, etc., but we really don't have any power other than the power of ideas in our minds, etc. Governments have power. Actors in the world, corporations, etc., have power. NGOs have power, etc. We need to align ourselves with them and form partnerships around problems. That's not easy. It sounds simple, but actually, what is the nature of a partnership with an outside entity? So you have to do that, and we think you have to do it from the beginning. It's not a partnership that says, we'll go do the academic work, hand it over to you, you'll decide what to do with it and do what you will. We think we have to be in that process of actually working with them on making things happen in the world. Then you need to identify problems. What are the problems that we should take on? I mean, everyone in the room can say there are problems. Income inequality, problems of droughts, problems of global warming, problems of this and that. All of us can identify those. That's great, but the goal here is to say we're going to identify problems that we can actually contribute to solving, and solving them in a discrete period of time. We say 5 years, it could be 3 years, 7 years, but something that gives us a discipline in our work that we can say this would not otherwise be addressed unless we put it together in this way. And it turns out that's actually very, very hard. Now, this meeting is one that we think is highly promising for a problem with outside partners, something that we could really do that would, the dealing with infrastructure around water, that's seems like a natural. So we're very eager to hear about what we might do. We need to have a whole system that nurtures, coaches, helps faculty along. Not everybody wants to contribute in this way. That's fine. Nobody's trying to change the underlying mission of individual faculty working on their project, advancing knowledge. That's all great. So there's plenty of space for all of this. We call this Columbia World Projects. We don't think that really captures the full dimension of what we're talking about, but there it is. So we've got a title for the moment. We may change it. As I said, it's a very serious enterprise. We're very interested in what you think of here today that might fit into this. In any event, I wanted to come and present this self-critique and proposal about what we're doing at Columbia. Thank you, Upmanu, for all of your work. Thank you for coming here, listening to me today. Thanks.
So thanks very much, President Bollinger. We've been very excited over the last year or two as this thinking has been evolving at the university, and we are keen to see where we end up. And I would join in the invitation to you to help us come up with ideas for solutions so that we can map those into a joint project. So we were going to have President Pedro Pablo Kuczynski here from Peru, or at least we thought so. It turns out that Peru, which is normally considered a fairly arid country, is undergoing significant flooding as of the last few weeks. Another wonderful climate event that's brought to us by God, or climate change, or whatever you want to think. But what I wanted to do was quickly introduce the video that he has sent. And there's also a representative from the government of Peru who is right there, so we can talk to him some more in the breaks. So the President Kuczynski is very interesting, and I highlighted that in yellow there because he's credited with being the only world leader who has started an NGO dedicated to bringing water to people. Okay? So he definitely has a water interest. He's also on the UN high-level panel on water. The co-chair of that panel is actually, at the moment, is the President of Mexico. So I had reached out to them also, and I learned that a visit to the United States at the moment is not likely to happen. So with that, and the background of the president is in economics, but he's clearly a humanist and has been very interested in water issues. So with that, maybe we can start the video.
This is Pedro Pablo Kuczynski, the President of Peru, giving you the very warm hello. I'm sorry I could not be at the America's Water Conference that you're organizing. I wish I could be there, but we're facing our own water problems right now. As you may have read, Peru, the Peruvian coast, is suffering huge floods in the middle of a desert. So we're not equipped to handle so much water coming through our towns and coastal rivers. Peru is an important country in the world of water. It is the main source of the Amazon River, which flows from the Andes towards Brazil and the Atlantic. On the other side is the coast, which is a very long coast. As I explained in the White House the other day to President Trump, our coast is as long as Portland, Maine to Florida. And this coast is broken up by small rivers that come down from the glaciers and provide irrigation. And Peru has become a very important producer of specialty fruits and vegetables such as mangoes, avocados, asparagus. We're the world's biggest exporter of asparagus. We produce the world's biggest blueberries and so on. But right now, there's an avalanche of mud and water coming from the mountains and causing us a problem. This is the result of global warming and its effect on climate change. So in our own small way, we must work together to do what we can to slow down this climate change and hopefully halt it. The things that we want to do here is, first of all, forest the parts of the Andes that are close to these glaciers to attract rain and reduce the rate of meltdown of the glaciers. And secondly, tame the rivers, so instead of cascading down into the ocean, they come down slowly and fill up the water table and thus provide healthy irrigation. Now, I'm on the UN Water Panel, which is a group of 8 or 10 world leaders. Some are countries with deserts like Peru, some are countries with huge forests, also like Peru. And we're trying to reach an aim, which is that everybody in the world should have access to healthy, clean water and sewerage. That is very difficult to achieve, but that is our goal in this administration in Peru. Unfortunately, previous governments have neglected this area, and for example, in our 80 main towns and cities, virtually all of them are spreading sewage into lakes and rivers, including Lake Titicaca. So this is one of the things that in our 5-year mandate we have to change, and we're working on it at a feverish pace. I see in your agenda you're going to talk also about water and mining and how they mix or don't mix. In Peru, most of the mines, but not all of them, are at high altitudes, which is where the water originates. And so sometimes there are conflicts. Some companies have managed this very well, such as, for example, BHP in a huge mine called Antamina, and others have had difficulties and there have been confrontations. One of the things that we are doing is we've created what we call a social advance fund, which devotes public resources into areas where we know there will be one day mining development, so that we put in schools, health systems, roads, environmental controls in these areas to minimize the conflicts and also give these very sparse populations access to the type of services which everybody ought to have. I have many things to say about water. I am not a hydrologist, I'm not an engineer, I'm an economist, as your director, Jeffrey Sachs, who's an old friend, knows, and I'd like to say saludos to Jeffrey, who knows this part of the world very well, and wish you all the best in this very important meeting that I'm very sorry I could not attend. Many thanks.
So you can see why, of all the world leaders, we are very happy to have the President of Peru talk, because in a few minutes, he captured the essence of all the issues that one has to deal with on water, and is clearly signaling that they are intending to make serious progress on this issue. So in terms of a partnership for the Columbia World projects or anything we try to do, Peru emerges under the leadership of President Kuczynski as a very attractive option for us. So to start with, just to lay out the context, why move from the US to the Americas? Typically, people think there's a dichotomy. We are a developed country in the United States, and there are all these developing countries, and their problems are probably very, very different from ours. In fact, what's talked about is that in those countries, getting access to drinking water is a big issue, and we think we don't have that problem. At lunch, one of the videos prepared by a water lawyer in our group, Madison Condon with some others, will be played, and it talks to the issue that today in the United States, we have around 2 million people without access to running water, and probably a lot more people without access to safe drinking water, because we have no clear way of assaying that. Okay, so there's that issue in common. The other issue is that as we look at infrastructure, many in the United States have been hearing that we have decaying urban water infrastructure, and this is manifest in the sense of main pipes that break all the time and so forth. What we don't talk about as much is larger infrastructure in the same way that President Kuczynski was talking about, taming the rivers, making sure that there are fewer damages. We have now reached a point where in the United States, the needs for renewal of infrastructure put us on par with the need for infrastructure in developing countries, both for major and urban water infrastructure. So that's one common element. And for that, in the 21st century, from the engineering perspective, but this is also the financial perspective, because those two cannot be separated, and that's the point I'll try to make. We need novel infrastructure designs that mesh with current investment opportunities and ways to deal with some of the risks that come from the factors that I list below: climate, changing energy platforms, changing preferences for food and other aspects of life, and globalization, supply chain, and corporations, which map into opportunities for investment, but are also at the same time sources of risk when, as we are seeing in our country today, we are retrenching very strongly from a globalization perspective today. So people who subscribe to that might get into that. So I'm going to start with a few examples. The first one is dams in the USA. So this is a picture showing dams, and if the color is red, that's a dam listed as a high hazard dam. If it is yellow, that's listed as a low hazard dam, and that's what you're seeing there. There's 88,000 dams in the US that are in an inventory of dams which are higher than, I think, 5 or 15 meters, I forget now exactly. The vast majority of these dams are not federal dams. And the significance of that is that the federal dams do have some attention from the US Army Corps of Engineers or the Bureau of Reclamation in terms of dam safety. The vast majority of dams that are not federal dams, we actually do not have a story on. Okay? So if we now look at why this becomes a concern, when these dams were designed, they were designed to have a economic life of around 30 years, a physical life of around 50 years. And if you look from this graphic, the vast majority of the dams in the US now are beyond their physical design life. Okay? So where this comes up, and the same sort of story actually applies to levees. There are 30,000 miles of levees protecting people from floods across the United States. And again, the color scheme here is red are federally owned, and the non-red colored ones are privately owned, and the ones that are federally owned are about 30% of the overall 30,000 miles of levees. Now imagine if these were to fail, what could happen? And that particular illustration we have seen. It was attributed to Hurricane Katrina, but in reality, it was the failure of a levee during that particular event, which had only a little bit to do with the fact that that hurricane was happening at that particular time. Okay? It was basically lack of maintenance and lack of inspection of that particular structure that led to that big disaster. But overall, there's a bunch of examples here. So we have the Katrina one, we have the Oroville Spillway, the highest dam in the United States. And it turns out that the spillway was a bunch of concrete patchwork, a few 12 inches thick, that people had not really been investing in. There was, in about 10 years ago, it was highlighted that this was something that was a problem. And the net result was that even though President Obama sent ARRA funds to California, nothing actually was done. So now to fix this spillway is a $100 million effort. And today's newspaper has a story saying, well, they better fix it before the fall, because if they don't, then this is going to be a much bigger problem. Okay? So similarly, on the left frame here, there are 3 tailing dams, a different kind of dam, that failed in the last couple of years: Canada, Colorado, and Brazil. And each one of these has a significant environmental or human impact. And the reason I highlight those is this is a nice example of a private dam rather than a publicly owned dam that can have significant impacts. And it's also tied to activity that is very economic development oriented, especially in the rest of the Americas, okay, but even in the United States. So this is a challenge that we have to think about, because as you think about changing climate into the future, more extremes on the wet side and on the dry side, historically we have buffered them with dams and levees. If we want to decommission those, because that's totally a choice, then we need to move a bunch of people off the floodplain or come up with more creative ways, such as issuing lifeboats to everyone in advance, right? So we have to think about some of these things from that perspective. Another area of infrastructure, which is the urban infrastructure or the safe drinking water aspect, I'm highlighting the United States here because this issue is well defined for the rest of the Americas to some extent. So we had Flint, Michigan. Everyone knows about that particular story, or you won't be here since you know something about water. But look, one of the fun stories I have is I got interviewed on the same day by The Guardian. That's that story there. At least 33 US cities used water testing cheats over lead concerns, right? So that story had appeared that day. I had not seen it. The Guardian folks interviewed me. They didn't bring this up. In the afternoon, the Chinese news agency Xinhua came and asked me, the first question they asked was, why is the American government and why are the American utilities poisoning the American population? I was going, no, they're not doing that. And they said, sure they are. You should read The Guardian. And I was saying, no, I know all about The Guardian. They interviewed me this morning. So then these people looked at me like I was a totally uninformed human being. So I said, hang on, stop the interview. Let me go check this out. And sure enough, that story was out there. And there are many such stories. And one of the challenges that I wanted to highlight with this particular slide is, we have perhaps water quality testing at the utility. We actually do not know necessarily what's being delivered at the tap where people are drinking it, especially in areas where we have lead exposure because of legacy issues, especially in areas where the pipes could be getting cross-contaminated, and especially in areas where we have poverty. So that's a uniform challenge that we face here as well as in other countries. And the framing that I'm putting before you is what I said right in the beginning. We need to think about a design of the infrastructure for the 21st century for the Americas across the board. Okay, so now talking about who's going to do this in terms of money, because things don't happen otherwise. So this graphic is from something Ed Pinero sent me just yesterday. So real-time adaptation to information in work here. So the bottom line is the red curve there, and you can't see the chronology. That starts in 1970, and that brings us to the present time. So the water investment is the red curve. The other infrastructure elements, transportation, et cetera, electricity, federal investments in those infrastructure elements are those other curves. So what you see is that in constant dollars, those investments have remained about the same, but the water infrastructure investment now is 20% of what the federal government invests in other forms of infrastructure. So it's not a surprise that we are looking at renewal, and graphically, those numbers are shown down there as well. So the IT infrastructure, internet, for example, per capita investment from the federal government currently is $250. For water is $11. So it's not a surprise that we all have smartphones and we connect to each other, and we eventually will get to drink water. Yeah. Okay. So I wanted to give you also an example of thinking towards what could be an infrastructure of the future. So thinking about needs in developing countries as well as ours, we look at perhaps the energy industry where what you're seeing at the moment is a significant democratization of access to electricity across the world, coming from renewables, solar and wind. You can plop these things anywhere. The cost of those have now come below the cost of traditional energy producers. It's remarkable. So why can't we think in a similar frame here to some extent with water? Because organically, when NGOs work in the developing communities, that is indeed what they're trying to do, except it never gets interconnected to anything, okay? And so some of the ideas here are we can start looking at buildings functioning as both solar collectors and water collectors simultaneously. There's no reason why that cannot be done. It's actually conjunctive. Then the question is, can we have point-of-use treatment and reuse systems? We actually have the technology to do that today. The National Institutes of Health and EPA will not allow you to generally do that if you're connected to a utility because they're concerned about the safety of the user. I made the point earlier that we actually don't really know what the safety profile of the user is. So one of the things that's emerging are inline water quality sensors for key contaminants or indicators. If you bring those into a system like this, which is still connected to the grid, you start overcoming some of these issues. So design for the future now has to actually leverage several of these aspects. And because we are investing heavily in the internet, that's actually a positive because these sensors could then be connected, and if things are not working, there's a variety of levels at which action can take place to actually address that situation. The scales at which this happen don't have to be restricted to a building. We can think of these systems as being deployed at the neighborhood scale or whatever. Now, this is a business issue. You know, how somebody can make money by running a business at a different scale will depend on the setting that you're working with. Last sort of point that I wanted to bring up on trying to set the stage for today's discussion is we hear a lot about climate change, and we hear a lot about how we need to design smartly in the future for a changing climate. That sounds wonderful. The problem is we actually have very little precision about what the future of climate change holds in terms of infrastructure design that we should strictly do that with. In some cases, people have scenarios that perhaps should motivate thinking. So for example, people have argued that sea level might rise by about 2 meters. Okay? So, okay, we maybe want to think a little bit about what we want to do about that. But in most other things, it's not clear. So if we want to be smart about that, one of the examples that I wanted to motivate is there are many people who have heard of a 100-year flood, and we design for protecting people from the risk of a 100-year flood. People also talk about no one really understands what a 100-year flood is because if you just had one, people think it'll be 100 years before it happens again, right? And then in New Jersey a few years ago, we had 3 100-year floods in the same year, and people jumped up and said, oh my gosh, this is truly proof of climate change now, right? Now, one of the things we also learn about the climate system is this thing I put in the center called decadal variability. So over the United States and over the Americas, what we do know is that there are regimes of variability where different parts of the region stay wet, relatively wet for 20 or 30 years, and then they flip to being relatively dry for 20 to 30 years. So what that means in terms of this 100-year flood is that in the dry regime, that's a 200-year event maybe. In the wet regime, it's a 20-year event. So your protection level is not actually fixed. So if you now think of climate change into the future, which we don't understand, we are screwing up even that logic further. But the point I have is that as we think of new infrastructure, whether it is for controlling floods and droughts, providing irrigation water through canals, or looking at green infrastructure, the way we have to think about the risk profile is a risk profile that is time varying and dynamic. So some things can be dealt with infrastructure. Some things will require financial securitization because there will be losses and we need a way to pay for them. And some things need to be thought in terms of what kind of financial instruments can be put in place to improve preparation during the decades that we really need it. okay? Rather than perpetual budget items on these things. And finally, we might need lifeboats for people as well during some periods, to stay with that theme. Okay, so to give you some examples of more technical things that I said we don't actually promote things we are doing, but this is an example of something we are doing in Pernambuco in Brazil. So I wanted to stretch out a little bit out from the Americas and show you an example of that. The idea here is Pernambuco is arid land. On the east part where the coast is, it's wet. As you go inland, it's dry. They have a bunch of rivers. They've built a large number of reservoirs that are interconnected to a certain degree and connect to a large number of communities. Now, what has been happening there is that when these people start delivering water, they deliver water from reservoir A to the city that's sort of close to it. Then they run out of water. So then they start pumping water from another reservoir, then they run out of that. You see where this cascade is going. And what they discussed with us was, well, could you come up with a way by which we can radically reduce the cost of operations, because somebody paid for the dams, but now we are kind of stuck with doing this particular game. So the reason I bring this up is that what we've been doing with them is developing the capability to do season ahead forecasts on a rolling basis for how much rainfall they can expect, and then coming up with an optimization scheme which is invariant to the uncertainty in the forecast and actually comes up with a way to assure what the supply would be at the lowest possible cost, including the cost of failure. Okay? So what this does is that it takes an infrastructure design, which may have been designed, say, for a 100-year event, but looks at how things are evolving in an adaptive way and comes up with a way of managing that risk. This is technically feasible, and it's the kind of thing that could bring together different groups, the policy people, the economists, the engineers, as well as the legal side and the insurance community. Because once you have a scheme such as this that is set up, ensuring the overall operation for the whole state becomes feasible rather than individual units. Another area that I wanted to quickly point at was Peru, because obviously we are in love with Peru here. So the economic development aspects of Peru link very strongly with mining. Mining accounts for a significant percentage of the economic growth of Peru. So in terms of water, what we are very interested in is making sure that the society is benefiting in the appropriate way and is not exposed to hazards, so that this enterprise can continue from an economic development perspective and also delivers the appropriate returns to the investors. So what we are trying to do there, jointly with the government of Peru, is to devise a system that brings together the mining companies, the communities, as well as the government organizations into a modern science-based approach to early detection of problems with regard to water quality, which is one of the big issues here, which then gets mapped into attribution of who actually is causing those problems, and not waiting for the mine closure and remediation, but getting action on that right away to forestall conflicts. So again, the framing here is infrastructure on the IT side in this particular case to achieve these goals. The last sort of slide that I have here is looking at water, energy, food, climate, and I know some of the panelists will talk about this. And the idea here in the lower picture that you're seeing is that of precision agriculture. This is something that I think is important because around 80% of water that is consumed, planetary water that is consumed, comes from agricultural irrigation uses. It's important to have this consumption because the productivity of food is roughly double or triple that for non-irrigated agriculture. It's also a way of buffering droughts. So we have to have that, but we want to improve the precision of that particular process, and we can get 30 to 40% improvements in water usage in this particular enterprise. So now think about the numbers. 80% of water is used for agriculture, for irrigated agriculture. If I save 30% of that, that's 24% of total water. That's as much water as the rest of the communities are using altogether. This is the place where the water for the future comes from, not necessarily from desalination, although in some cases that might be fine. So thinking about that, the question is that if you mobilize that water, then it could be made available to other groups. And obviously, there's going to be spikes in the values associated with trading when there are droughts versus wet periods. So one has to think about the business model around that. But one of the ideas that I'm pitching here is that it could be that if you're an investor in some aspects of water development, even for the urban sector, you are looking at this particular enterprise as an investment to create an opportunity.